In CP3-2 Part 1, you're going to be able to use algebra to write equations for perpendicular bisectors. Let's quickly review what we've learned about circumcenters, intercenters, and orthocenters. Let's remember that the circumcenter is made from perpendicular bisectors, and it looks like that picture. The circumcenter is equidistant to each of the vertices of the triangle. An incenter is created from angle bisectors, and it's equidistance to each side. And then the orthocenter is created by altitudes, and there's nothing special about orthocenters. Today we are going to focus on the perpendicular bisectors, and we're going to work on creating lines, creating equations for these perpendicular bisectors. In part 2, you're going to take it a step further, and you're going to actually set two of those equations equal to each other to determine where they meet, where that circumcenter actually is. Let's recall that circumcenters are created from three perpendicular bisectors. The perpendicular part reminds me or tells me that I need a slope that's an opposite reciprocal. The bisector part tells me that I need to find the midpoint between two vertices. Once I have the midpoint and know that the slope is the opposite reciprocal, then we are good to go. Today we are going to need to recall these three formulas. So let's first recall the slope formula. Remember, it's y2 minus y1 divided by x2 minus x1. You can also think about it as the change in y over the change in x, or rise over run. For the midpoint formula, that's the average of the x's, then the average of the y's, so that more specifically would be x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. That's just finding those averages. Then you're going to take both of the things you find from the slope and the midpoint formula, and you're going to plug it into the point-slope form of an equation. So y minus y1 equals mx minus x1. So let's practice. Example number 1. Find the equation of a perpendicular bisector of a line segment between 6, 8 and 10, 0. So some things we need to find. We need to find our slope. And then we want to use that slope to find the perpendicular slope. And then you also want to find your midpoint. These are the three things that we need using those points. So for our slope, y2 minus y1 over x2 minus x1. 0 minus 8 over 10 minus 6. Negative 8 over 4, which equals negative 2. So that's the slope of the line. For our perpendicular bisector, we need the perpendicular slope. Remember, it's the opposite reciprocal. So right now we have negative 2 over 1. It's going to become 1/2. That's for our perpendicular bisector. And then we need to find our midpoint. Our midpoint, average of the x's, average of the y's. So remember, x1 plus x2 divided by 2, y1 plus y2 divided by 2. So I'm going to add the x's, 6 plus 10, divide that by 2. Add the y's, 8 plus 0 divided by 2. And we get 16 halves and 8 halves, or the point is going to be 8, 4. For our perpendicular bisector, for the equation, we're going to use our perpendicular slope of 1/2, and we're going to use our point, our midpoint, 8, 4. We're going to plug it into our formula, our point slope formula, which is y minus y1, mx minus x1. So y minus 4 equals our slope of 1/2, x minus 8. And that is our answer. Example number 2, find the equations of the perpendicular bisectors of the triangle with vertices A, B, and C. So in this case, we are looking at 3 points A, B, and C. And we want to find all of the perpendicular bisectors. So we're going to find equations for each of those lines there. Okay. When we do that, we're going to be looking at AB, we're going to be looking at BC, and we're going to be looking at AC. And all of the things we need to find, remember, we need to find our slope, which is our M. Then we need to find the perpendicular slope using that M. And then we need to find the midpoint. And that's going to help. All right, so let's first look at points A and B. To find the slope, we need to find the change in y over the change in x. So 3 minus 1 over 4 minus -2, which is 1/3. The opposite reciprocal for the slope would be -3. And then our midpoint would be the average of the x's, average of the y's. So -2 plus 4 divided by 2. And 1 plus 3 divided by 2. That gives us our midpoint of 1, 2. For our equation, we're using our perpendicular slope and our midpoint. Y minus y1, which is 2, equals our slope of -3, x minus our x1, which is 1. So that is the perpendicular bisector of line AB. All right, now let's do the same thing for BC. So again, for the slope, you're going to find the change in y over the change in x, which is -2 over -8, which equals 1/4. Yes, you can show all of the steps, and if you're struggling with that, please show the subtraction for the y's and the x. Perpendicular slope, opposite reciprocal, will be -4. To find your midpoint, you're adding the x's and dividing by 2, then adding the y's and dividing by 2. So for our x's, if I add and divide by 2, I get 0. For the y's, if I add and divide by 2, I get 2. For our equation, remember we're using the perpendicular slope and the midpoint. So y minus 2 equals our slope of -4, x minus x1, which is 0. And that is our equation. All right, now let's look at line AC. So we're going to find the change in y, which is 0, over the change in x, which is -2. That becomes 0. Remember, that is a slope. That's a horizontal line like this. Remember, the opposite reciprocal of that, or one that would be perpendicular, would be one that's completely vertical, which is undefined. Now let's remember, with our undefined slope and our vertical lines, they're going through x. So let's remember that those are always the x equals. So when we're considering our midpoint, we want to know what the x value is. We're going to find the whole midpoint, but that's the x value is what's going to be most helpful for us in this problem. So add the x's, divide by 2, we get -3. Add the y's, divide by 2, we get 1. Because this is a vertical line, remember those vertical lines are x equals whatever the number is for x. So in this case, our line is x equals -3. It's going to end up being a straight line through x equals +3. All right, let's take a look at another example. Find the equation of the perpendicular bisectors of the triangles with vertices D, E, and F. So again here, to find our equations, we're going to need our slope, we're going to need our perpendicular slope, and we're going to need our midpoint. We are using, or looking at, sides DE. We're going to look at all three sides, DE, and then EF, and then DF. For each of these, we need the slope, the perpendicular slope, and the midpoint. All right, for DE, looking at D and E, our slope would be change in y's, -6, or 6 minus -6, 12 divided by 4 minus 0. 12 divided by 4 is 3, so the perpendicular slope is -1/3. Our midpoint, add the x's, divide by 2. 0 plus 4 divided by 2 is 2. -6 plus 6 is 0. Divided by 2 is still 0. For our equation, we're using the midpoint and the perpendicular slope. Y minus y1, which is 0, equals our slope, -1/3. X minus x1, which is 2. That is our equation. Go ahead and try E and F and then D and F on your own. And when you're done, press play to check your answer. Go ahead and check each of your answers. If you made a mistake, try to identify what you did wrong. All right, in our fourth example, we are again finding the equations of the perpendicular bisectors of the triangle with vertices G, H, and J. So again, just like before, we need to find the slope, the perpendicular slope, and our midpoint. We are going to be looking at GH, GJ, and HJ. For GH, for our slope, we're going to do 5 minus 0 to get 5, and then 0 minus -4, which is 4. The opposite reciprocal is -4/5. Our midpoint, we're going to add those x's. -4 plus 0 is -4. Divided by 2 is -2. 5 plus 0 is 5. Divided by 2 is 5/2. So our equation is y minus y1, which is 5/2, equals m, which is -4/5. X minus x1 would be -2, so x plus 2. Remember, we are using the perpendicular slope and our midpoint for that equation. Go ahead and try the other two and then press play to check your answer. GJ's equation should be y plus 3/2 equals 14/3, x minus 3. And then HJ, the equation y minus 1 equals 5/4, x minus 5.